Hi everyone, it's Carrie, and we are going to be talking about bivariate data analysis today, just kind of building off of the univariate data analysis work that y'all did in last week's module. So let's go ahead and get started. So we're going to just kind of have an introduction to what bivariate data analysis is in this video. So we're going to look at examples of what that is. We're going to be defining what bivariate data analysis is. We're going to be looking at concepts associated with it and illustrating it using class data that y'all have collected. And so the main question to think about now and just kind of throughout this module is, what is bivariate analysis? And you probably have a pretty good idea coming off of the univariate data analysis chapter from last week. So with that being said, here is our first example of what a bivariate analysis is. And this will kind of appeal to any football fans, especially of NFL teams. And so here we have information regarding total team salaries and the number of wins that they have. There are discussions that wealthier teams tend to do better because they have more resources. And so this was kind of a way of mapping that out and seeing if these two variables correspond in that way, and seeing if increased salary does mean increased wins. So down here on our x-axis, we have the total team salary, and then over here on our y-axis, we have the team wins. So it's our first example. Our second example, a little topical now, is looking at the relationship between COVID-19 narratives that involve different conspiracy theories and believability scores. And this is actually coming out of the BMC Public Health Journal. So this is a real study, something that you can look up. It is pretty interesting, and it just kind of asks people about different conspiracy theories related to COVID-19 and to kind of gauge how believable they thought those were. So an example was 5G, the dawn of 5G corresponding with COVID-19 and leading to COVID-19. And so here we have that conspiracy theory, that being one of our independent variables on this x-axis. And then we see that the believability of that conspiracy theory related to COVID-19 is scored here. So lower scores meaning low believability skills, low believability, and higher scores meaning higher believability. And just to kind of explain what these profiles mean. So the profiles came about when conducting this study, and they essentially just correspond to different belief profiles that actually came out of asking people about believability of these COVID-19 narratives. So really interesting. Check it out if you want, but this is another example of a bivariate analysis because we're looking at our narratives involving conspiracy theories and then believability scores related to that. So our last one, also COVID-19 related, involves the Pew Research Center asking adults in the US that are following the news, just kind of about how their political party relates to how well they follow news of COVID-19 and how their age does as well. So we've got three different sects here. So the first up top just being the percentage of adults that were surveyed and how closely they were following news about the outbreak. And so here we can see that people could choose that they were very closely following, fairly closely following, or not following it really at all. And what this top bar tells us is actually indicative of a univariate analysis because it's strictly asking people how closely they're following the news. So that's the only variable you're interested in here. But when you move down into these two sections, so this first section, it's how closely these same people are following news of the outbreak, plus how they identify politically. Are they Republicans or do they lean Republican, or are they Democrats or leaning Democrat? Same goes for here, how closely they're following news of the outbreak, plus their age, and those are just kind of in those different ranges that we've seen come up a lot when conducting research. So, defining bivariate data analysis. So bivariate analysis involves investigating how two variables, an independent variable and a dependent variable, are related to each other. So as we saw, we'll go back to this one because it's a little easier to follow. Here we've got our independent variable being those total team salaries and how that relates to team wins, our dependent variable. So it's two variables. That's all we're interested in. So going one step beyond your univariate analysis, but not quite moving into more than two variables at that point. And so a couple of ideas to kind of keep in mind when discussing bivariate data analysis is what an independent variable is, what a dependent variable is, and then what cross-tabulation tables are. And y'all seem to be fairly familiar with all of these terms already, but we'll kind of just talk a little bit more about what these mean in this presentation. So to kind of recap what an independent variable is, it is considered to be the cause in the relationship. So again, going back to that NFL example, it's the total team salary. So total team salary is affecting the wins that these teams have. So for the purpose of illustration and analysis in this class, we're only going to use categorical independent variables that have two attributes. So what that means is that you could have an independent variable that could have more than two attributes. So you could ask people if their favorite color is, or you could see if favorite color leads to something, and favorite color could be pink, green, purple. But for this case, we're sticking solely to pink and green, for example. You wouldn't add another attribute to that. And so kind of going back to what y'all have done with your earlier class data sets, think about these two attributes in terms of wanting to know someone's sex, if they're male or female, you only have two options there. Or when we were talking about TV genre, after doing that work with the Netflix, Hulu, and Amazon shows, I think those were the three platforms, whether or not a show is a comedy or if it's a completely separate genre. So you wouldn't do comedy, drama, or other. You would strictly do two, so comedy or other. So that's how you have two attributes. So our dependent variables are the outcome in the relationship. So going back to our NFL example, that would be the number of wins, which is affected by the team's salary. So for this class, we'll only use categorical dependent variables that have two attributes. So the same thing as what we just covered in the last slide. And so again, kind of going back to those class data sets y'all are already familiar with, favorite color could be pink, purple. So that's one attribute or other being your second, and then IMDb user score, which would be low or high. So you could take anything that had a 7 or an 8, a 7 or an 8 and above as high, and anything below that threshold as low. So just kind of a way to take numerical scores, which is what we have with the IMDb user scores, and then group them. So you can get two attributes instead of many. So cross-tabulation tables. So once you've identified your independent and dependent variables, you can construct your cross-tabulation table. So we're going to kind of just look at an example here, and it again pertains to the data sets y'all have already worked with. So you can see here we have one variable being sex. So you can be male, you could have male or female there, and then favorite color, pink or purple being one, and then other being your second. So In order to fill out the table, you count the number of peoples, which you count the number of people. So that's cells A through D, and that will correspond to the combinations of the attributes. So the amount that we would have in A corresponds to the number of male identifying participants that picked pink or purple as their favorite color. That's C is just female identifying participants that picked pink or purple. And then B is male identifying participants picking other. D is female identifying participants picking other as well. So that's just kind of what these look like. And then down at the bottom, you have that total section. So that's kind of where you can, and on the side to count everything up. So after counting the number of people with each combination of attributes, you calculate your percentages for cells A through D and for the totals based on your independent variable. And so that would mean our independent variable, someone identifying as male or female, affecting the favorite color that they choose being our dependent variable. So they're either choosing pink or purple or other. So with that being said, we're going to kind of just look at how you actually fill this table out beyond just using those A, B, C, D attributes. So if we have our total number of participants here, so we had 107 male identifying participants and 186 female identifying participants. We also want to know our totals down here. So we had 73 total participants picking pink or purple, and then 220 total participants picking other for favorite color. So then you can take these totals and you can make sure that they correspond to one another. So you can add these two up, make sure they both, or they would come out to 293, and then you would go through, add these up and make sure they both come out to 293 as well. So to fill that out, we have 8 male identifying participants picking pink or purple as their favorite color and 99 picking other. And then 65 female identifying participants picking pink or purple as their favorite color and 121 picking other. So now we have it filled out. So it would just be your independent variable and then whatever they pick as their favorite color. So that's just all adding up. That's nothing complicated. But you've got all these raw numbers, so that's great, but you need to find the percentages so you can accurately compare, because let's just try and compare this 8 to this 65. So you may have fewer male identifying participants picking pink or purple, especially when it comes to raw numbers, than you would female identifying participants, but that isn't necessarily indicative of the percentage, the differences in percentage, because as you can see here, you have 107 male participants and 186 female identifying participants. So those raw numbers are different in and of themselves. So you want to know the 8 out of 107 and 65 out of 186 and kind of compare those percentages instead of just comparing the raw numbers. So you've got your raw numbers, you want to calculate your percentages. So these are the total, since these are just the total, so total for male identifying participants, total for female identifying participants, that's going to be 100%. And then here, since that is your independent variable, that's how you get those 100% there. Here, you have your dependent variable, but you're not going to, you'll have these be split up since you're comparing, it's the male identifying individuals plus the female identifying individuals. So that's how you get these different percentages here. So it's not 100% on their own, it's 100% together, if that makes sense. So you can see here that 24.9% of our participants picked pink or purple and 75.1% picked other, which adds up to 100%. And so then you can see, you could just take 8 divided by 107 and you get 7.5% as the percentage of male identifying participants picking pink or purple, and then 65 divided by 186, and that's how you get 34.9% of your female identifying participants getting that amount as well. So we've got our percentages, we've got our raw numbers. We can see here that about a quarter of our total participants picked pink or purple as their favorite color. Oops. And here you can say, or you can see that the remainder, so the other 3/4 of the participants picked other colors as their favorite colors, but strictly picked other since that acts as our other variable. So you can kind of do the same thing with the IMDb user score. Again, data that y'all are already familiar with. So if we had 25 shows identifying as comedies total and 56 identifying as other, we've got a total of 81 down here. And that means that the total in the low score category being 48 and the total in the high score category being 33 also adds up to 81. So we have 20 and 5, and then 28 and 28. So got all our raw data, but we again have to go a step farther and do percentages. And for our independent variables, we've got our 100% there. But again, we don't have 100% down here. We have 100% adding up our results together. So same thing here, we can see, and if we want to directly compare percentages here, we can see that even though there were more, okay, we'll look at the high score. So even though there were more TV shows that fall into the other genre, so they're not comedies, they can be any other genre. We have 28 here, which is 50%, and only 5 here being 20%. The percentages aren't necessarily as far off as we would expect them to be, especially given these numbers. And if you look here with the low scores, you may have 28 here acting as 50% and 20 here acting as 80%. So if you just look at the raw numbers and you say, well, this is 20 compared to 28, and this is 5 compared to 28, you won't necessarily get the same level of analysis or an accurate analysis as you would comparing the actual percentages out of these total numbers here. So just kind of keep in mind the importance of calculating your percentages once you have all of your raw scores. So essentially these cross tabulation tables just give you a quick way to see if two variables are related to each other. And they can be used with categorical variables, and to keep things simple, we're using variables with only 2 attributes or categories each, which we talked about, and that'll be for both your independent and dependent variables. But you can use these tables with variables having 3 or 4 categories as well. So again, note, we will be doing 2 attributes. You can go beyond that if you choose. And we'll kind of talk more about that in a couple of weeks when we move into some different types of statistical analysis. So just kind of keep cross-tabulation tables in the back of your mind until then. So to kind of just recap what we've accomplished, we've reviewed some examples of bivariate analysis, which is great coming off of the discussion of univariate analysis in the last class. We defined what bivariate analysis is, illustrated it with some class data, and now we get to move on to the rest of this week's video lectures, and that's going to be with our second one, looking at practice using bivariate data analysis, and then with the third, just kind of overviewing your assignments for this week. And an important thing to keep in mind is that you will have a homework due April 4th at 11:59 p.m., and that is your 5th homework in this series of homeworks that y'all have done. So thanks so much for sticking with me through this first video for week 11, and I will see y'all in the next one.